Okay, number 16, again, we're simplifying a radical expression that contains variables. So we want to, it's a square root, so let's factor 50 into a perfect square times another factor. All right, so 25 is a perfect square, so we're going to use the factorization 25 times 2. All right, and 25 is a perfect square, so I'll circle that. Then we have x to the 25th. All right, so this is not a perfect square because 25 is not divisible by 2. So let's factor this into x to the 24, that's even, times x. So this is a perfect square because it has an even exponent. And y cubed also we want to factor into a power with an even exponent. Okay, so we'll factor y cubed as y squared times y. All right, and now we'll take the square root of 25, that's 5. The square root of 24, just divide 24 by 2, and we have x to the 12. And the square root of y squared is y. So in front of the square root, we have 5x to the 12th y. And left inside the square root, we have 2xy. In number 17, we want to simplify the cubed root of 128. So let's factor into a perfect cube times something else. Let's remember our perfect cubes. 2 cubed is 8, and 8 does not divide into 128 evenly. 3 cubed is 27, also does not divide in evenly. And 4 cubed is 64. Well, 2 times 64 is 128, so that's what we're looking for. We're taking the cube root of 64. The cube root of 64 is 4. So this comes out as a 4. So we'll have a 4 in front, and 2 remains inside the cubed root. In number 18, we're adding two radical expressions, and they're not like radicals. They would be like radicals if they were both radicals were the same. So what we do in cases like this is we try to simplify the radicals, and maybe the simplified radicals will be like radicals. Well, we can't simplify the cube root of 5, so we'll just leave it like that. But the cube root of 40, well, we can factor 40 into a perfect cubed. 8 is a perfect cube times 5. So we can bring out the cube root of 8. That's 2. And so we have 5 times the cube root of 5 plus 2 times the cube root of 5. So now we do have like radicals, and we just add the coefficients of those like radicals. And we have 7 times the cube root of 5. In number 19, we want to subtract these radicals, and again, they're not like radicals. Now, what I suggest you do here is simplify whichever one is easier. So this one's easier to simplify because 45 is a small number. So we'll simplify square root 45, factor it into 9 times 5. 9 is a perfect square. So we see that here we're left with radical 5, so we want to be left with radical 5 here as well. So now we're just going to factor 320. Well, 5 is a factor of 320 into 5 times something else, because we do want to be left with a 5 here. So we'll divide 5 into 320, and we get 64. And now 64 is a perfect square. Square root of 64 is 8. So we have 8 times square root 5 minus 3 times square root 5. So now we have these like radicals, and we're just going to subtract the coefficients. 8 subtract 3 is 5. So the result is 5 times square root 5. In number 20, we're just multiplying these radical expressions. So we multiply the coefficients, 5 times 2, and radical 3 times radical 3 is 3. You can think of it as radical 9, which is equal to 3, or you can go straight to 3. So this is 10 times 3, or 30. In number 21, we're multiplying radical expressions. So remember, we're going to follow the following rule. Square root of a times square root of b is the square root of ab. In other words, we multiply underneath the radical symbol. So let's do that here. So we have square root 25. We have x cubed times x, that's x to the 4th. And y times y to the 5th, that's y to the 6th. And we ended up with a perfect square. Square root of 25 is 5. Square root of x to the 4th is x squared. And the square root of y to the 6th is y cubed. In number 22, we're multiplying radical expressions. So we're going to FOIL these. So first we're going to do first times first. 3 times 2 is 6. And then we're going to do outer. And this would be minus 9 times root 3. And then we're going to do the inner, and that would be 10 plus 10 times root 3. And then we'll do the last, so that would be minus 15 times square root 3 times square root 3 is just 3. All right. So here we have 15 times 3. So here we have, let's say, minus 45 right here. Okay, minus 45. And now we're just going to add like terms. So we have 6 minus 45. So that's a negative 39. And then we have minus 9 plus 10, that's plus 1 root 3. So that's the product. In number 23, we're dividing two rational expressions, and we're going to use the following rule. Square root of a divided by square root of b is the square root of a over b. In other words, we just divide underneath the radical symbols. All right, so that's what we'll do here. Let's write everything underneath one big radical symbol. And we just work underneath the radical. So 8 divided by 2 is 4. And then we have x divided by x to the 5th, that's x to the 4th. And these y's just cancel. So we have the square root of 4x to the 4th. Now notice that this is a perfect square, so we'll take the square root of that. And that's 2x squared. In number 24, we're rationalizing this denominator. That means we want to remove the radical from the denominator. So if we multiply top and bottom by square root 3, then we'll do that. In the numerator we have 6 root 3. And in the denominator we have 5, and root 3 times root 3 is 3. 5 times 3. So we have 6 root 3 over 15. Notice this reduces a little bit. We can divide top and bottom by 3. So we have 2 root 3 divided by 5. In number 25, again, we want to rationalize the denominator, but this time multiplying top and bottom by root 2 wouldn't do it. We'd still, because of the distributive law, we wouldn't get rid of the radical. So we use conjugates to rationalize denominators that are sums or differences of two terms. So we're going to multiply top and bottom by the conjugate of the denominator. That is the denominator with a negative sign or the opposite sign in between. The opposite of whatever's there. So let me just rewrite this. 3 plus root 2. 2 plus 3 root 2. So we'll multiply top and bottom by 2 minus 3 root 2, the conjugate of the denominator. I'll put parentheses around everything because we'll be foiling in order to do this multiplication. So first, the denominator, multiplying conjugates. Remember that the middle term, the outer plus inner, will have opposite signs and will cancel out. So we just have to do first, last. So first is 4. And last we have minus 9. Root 2 times root 2 is 2. Minus 9 times 2. So that's 4 minus 18 in the denominator. Okay, the numerator here will do a FOIL multiplication. 3 times 2, 6. The outer is minus 9 root 2. The inner is plus 2 root 2. And for last, we have minus 3 times 2. Root 2 times root 2 is 2. Okay, so let's just subtract 4 minus 18. That's a negative 14. And in the numerator here, we have a 6, and here we have a minus 6. 6 minus 6, so that's 0. And here we have, so these cancel. And here we have minus 9 root 2 plus 2 root 2. That's minus 7 root 2. Notice we have a little canceling here as well. We'll divide top and bottom by minus 7. And we have root 2 over 2. In number 26, we're starting to work with rational exponents or fractional exponents. So an exponent of 1/4 means a fourth root, okay? So or an exponent of 1/3 is a third root. So here we have an exponent of minus 1/4. So we're going to start by using the following rule. If we have a fraction to a negative exponent, we can take the reciprocal of that fraction and change the exponent to the opposite sign. So we'll do that here. We'll start by taking the reciprocal, 81 over 16 in parentheses, and changing minus 1/4 to 1/4. So now we're taking a fourth root of 81 and a fourth root of 16. The fourth root of 81 is 3, and the fourth root of 16 is 2. All right, in number 27, we're doing minus 27 in parentheses to the 2/3 power. So what we do here is first do the denominator, first do the root, and then we'll do the numerator. So first the root. So the cubed root of minus 27 is minus 3. So we'll do that. And we're still left with this exponent 2 that I put over here. So now we're just going to square minus 3 squared is a positive 9. All right, here we have an expression in parentheses involving variables. We'll again take the 2/3 root and again start with the denominator. sorry, we're doing exponent 2/3, and we're going to start with the denominator, which is a cube root. Okay, so first cube root of 8 is 2. Cube root of this power x to the 6, just divide that exponent by 3. 6 divided by 3 is 2, so we have x squared here. And the cube root of y to the 30th is y to the 10th. Now we still have this exponent 2 that I'll put right here. So now we're going to square everything. 2 squared is 4. X squared squared, that's x to the 4th. Y to the 10th squared, y to the 10 times 2, that's y to the 20th. In number 29, we're multiplying powers that have these fractional exponents. So we're using the usual rule of addition of exponents. X to the n times x to the m is x to the n plus m. When we multiply powers, we add exponents. So we'll do that here as well. We're just going to add these exponents. 1/5 plus 2 over 7 plus 3 over 5. We need a common denominator, and that would be 35. 5 times 7. So just in the exponent, we're going to add these fractions. Multiply top and bottom by 7 here. Here multiply top and bottom by 5. And here multiply top and bottom by 7. Just add those up. And we have 7, let's do 7 plus 21 is 28, and then 10 is 38. Now we're starting to work on some of the geometry problems. All right, and number 30 is about a right triangle. It says if one leg of a right triangle is 5 and the other is 12, what is the length of the hypotenuse? So we're going to use the Pythagorean theorem. And let me just write that down. Okay. This is the hypotenuse. It's opposite the right angle, and we always label that with a C. The other two sides are called legs, and we label them with A and B. And we have the following relationship: a squared plus b squared is equal to c squared. And that's the Pythagorean theorem. So in our case, we have a triangle. One leg is 5 and the other is 12. And we want to know the length of the hypotenuse. So using this relationship, the Pythagorean theorem, we write down 5 squared plus 12 squared is equal to c squared. So that's 25 plus 144 is equal to c squared. And that would be 169 is equal to c squared. So c is equal to the square root of 169, which is 13. In number 31, we want to find the second leg of a right triangle with hypotenuse 7 and leg 3. So one leg is 3, the hypotenuse is 7, and we want the other one. So we'll label like that. Okay, so we have a squared plus 3 squared is equal to 7 squared. So that's a squared plus 9 is equal to 49. Then just subtract 9 from both sides. And we have a squared is equal to 40. So a is the square root of 40. And let's just simplify that. Square root of 40, that's 4 times 10. And this comes out as a 2, so we have 2 square root 10. In number 32, we want to determine if 7, 24, 25 are the lengths of a right triangle. So let's draw a right triangle. And these sides, let's label the sides 7, 24. Make sure the largest side, 25, is the largest of these three numbers. Make sure you put that for the hypotenuse. So we want to see if the Pythagorean theorem is satisfied. That is 24 squared plus 7 squared equal to 25 squared? All right, that is 576 plus 49 equal to 625? And if we add these, we see we do get 625. 625 on the left and 625 on the right. So the answer is yes. 24, 7, and 25 are the sides of a right triangle. Number 33 asks us to find the area and perimeter of a rectangle with length 5 and width 3. So here's our rectangle. Labeled the sides. A rectangle has 4 right angles. All right, so the area is equal to length times width, so we just multiply the 2. And that's 15. Let's put in some units. Let's say these were inches. So that would be 15 square inches, or inches squared. And the perimeter is twice the length plus twice the width. So that's equal to 2 times 10 plus 2 times 3. 20 plus 6. And that would just be inches, not square inches. In number 34, we want to find the area of a triangle whose height is 4 and base 7. I'll just draw a picture over here. Let's say that's base 7, and here's the height, this perpendicular line, perpendicular to the base. So the area of a triangle is 1/2 base times height. That's 1/2 7 times 4. Half of 28, 14. Number 35, we're asked to find the area and circumference of a circle with radius 4. So let's draw a picture here. We have a circle. Radius 4. So let me write down the formulas for the area. The area is pi r squared, where r is the radius. And the circumference is 2 pi r. So in our case, the area is pi times 4 squared, or 16 pi. And the circumference is 2 pi r. 2 pi times the radius 4. That would be 8 pi.